So here are a few more practice examples to kind of practice this idea that we were just talking about. We need a common index here to be able to multiply this together. Okay, so one thing we could do this is put it into a fractional exponent or rational exponent. We could also get a common index by increasing the power and the root the same amount. And when we do that, so in this case here, I'm going to increase that by a factor of 2 and increase the exponent by a factor of 2. These two expressions are equivalent to each other. They're the same. Now, why would I do this? Well, it allows me to get a common index, which means that then I can multiply these together under the same index of 6, and I end up with x to the power of 21. Okay. Alternatively, we could have done this in exponential form, x to the power 5 over 6 times x to the power 8 over 3. To multiply these together, we need a common denominator, so we get 5 over 6 plus 16 over 6 to get my common denominator, and we end up with x to the power 21 over 6 is what we have here. Notice that we could leave it like this, but since there is a factor of 3 involved here, we can actually simplify this to the square root of x to the power 7. And that's the same thing here. This could be rewritten as x to the power 7 over 2, which is the same thing as square root power 7. So here we have indexes that don't match. So again, one strategy is to get the common index. So the lowest common index between these two is going to be 6. So I can do this. I can do the root 6. So I've increased it from squared to 6. I need to do the same to that power. And I have a power 3. Okay. Here I can do the same thing. I'm going to increase it from root 3 to root 6, which means I need to make sure that I apply the power here. So power 2, root 2 undoes each other, so these are equivalent expressions. Okay, so there's my power 5. Now I can apply my power, so I have root 6, a to the power 9 times the 6th root, a to the power 10, and this becomes the 6th root of a to the power 19. Okay, and we can actually simplify this. We can pull out a perfect power of 18, and we're left with just a to the power 1. Okay, so we can leave it like this if you want, but we can take out the perfect power 6s. There's 3 power 6s in 19. So here we have root, 5th root, 4th root. Okay, so I'm going to express this all in the lowest common root. And that would be, in this case, it looks like it's going to be 20, the 20th root. Hey, well, if I'm going to do that, I need to increase this by 10, power 10, and root 10. Okay, here I'm going to end up with 2 squared, and I'm going to have power 10. Okay, so I need to increase it by 2, and then I'm going to put make sure I keep the squared out there. Okay, and then I'm going to do this one to power, this is going to be power 20. Okay, our common, so we need to do it by factor 4. Here we're going to get a common root of 20, so I need to increase it by power of 5. By factor of 5, so there it is. I should maybe have dealt with that consistently, those two at the same time, but we know that that power and that power go together, so I'm going to end up with 3, index is 20, times 4, index is 20, that becomes 8, and this is index is 20, x to the power 15. So numbers times numbers, we get 12, index of 20, x to the 10, 8, 15, that's going to be 33. Okay, we can leave it like that. We can pull out the perfect powers. I'm just going to leave it like that. Okay, because at this point, there's not a huge advantage of taking the power 20 out of the root. So here we have a power x and index x. Okay, well, how do we deal with this? Okay, maybe we should just rewrite this all in terms of maybe a fractional exponent. I think that might be a little bit easier. So we're going to write this as 4. Let's redo this. So we're going to have square root of 4 is 2 to the power x. Here we're going to end up with a to the power 3 power x square root. Okay, so times 2. This becomes a to the power 7 fifth root. This becomes a to the power 4 root x. So I want to now, the reason why I did this, because I just want to deal with this with exponent rules, because I think that's going to be a little bit more easier because it's a little bit more familiar to me. So I need to group my bases that are the same. So I have base 2, base 2. Okay, so when I rewrite that, I'm going to end up with 2 to the power x plus 1. Okay, I have the exponent is x, and I'm going to want to add one extra factor of 2 to that, so it's going to be plus 1 times. Okay, so this is, remember, this is an x there. We're going to end up with a to the power, well, let's just do the numerator first, 3x over 2 plus 7 over 5, and let's just write that, 4 over x, like that. Okay, so we need a common denominator here to add that together. Okay, so I should highlight this here. This is where the 2 came from. So 2 to the power x plus 1, that's done. And this becomes a to the power, and I just maybe highlight, I'm just going to deal that part there. Okay, so we're going to end up with 15x plus 14 all over the common denominator of 10. Okay, so now we're just dealing with dividing by base a, which means we're going to subtract. So I'm going to write the subtraction first. So it's going to be, again, the 2x to the power 1, x plus 1 doesn't change. And then a is going to be 15x plus 14 over 10. And then I'm going to subtract that exponent of 4 over x. And to subtract exponents, we need a common denominator. The common denominator here, well, I'm missing a factor of times x, so I need to do the same on the top and bottom, and I don't change the value of that fraction. To get a common denominator here, I need a factor of 10. I need to do the top and bottom, so I don't change the value of the fraction. Okay, so notice I'm just dealing with exponent parts now, so all this stays the same. And so I end up with 15x squared plus 14x minus 40. There's my numerator that I can all have under the common denominator of 10x. So there it is. There is my final answer here. And now I have this really complicated looking exponent. However, it's all consistent with all the rules that I know for exponent rules and adding and subtracting fractions.